Hey everyone. So I think this is our second conversation around stuff around AI, and I think I didn't get to plan this out as good as last time. So I think there. Hey everyone. So I think this is our second conversation around stuff around AI, and I think I didn't get to plan this out as. Yeah, sorry, there was some feedback in my system. Just give me 1 second. Closing all the other stuff. Yeah. Okay. So I think we can kind of touch upon what we wanted to do. There are a few things which we'll be going through in what we can cover today, and I just want to like touch upon what we covered last time. So I think last time we had done something for stable diffusion. We were talking about how you can use automatic 1111. We spoke about a lot of configurations and how to achieve it, some examples around it, and that was like what we did last time. And just to give you a glimpse, like we took some examples like in painting, adding control nets, getting different outputs in that manner. So today we're going to explore another tool, and that tool is going to be focused on similar to automatic 111. We're going to use something called Comfy UI, but that's not the only thing we're going to cover today. We're going to also look into using something called diffusers or Hugging Face diffusers. This is a super interesting thing that I think if you're a programmer, I think this is what you should be basically be doing to get hands-on with writing your own pipelines or writing your own code for generating outputs, right? So I can speak loudly. Just let me increase the audio a little bit. I hope that's better. So I'm still used to using OBS Studio, so it's got a lot of controls on it. So I'm just increasing the audio a little bit better. Reverb, I hope that's fine. Okay. So just a bit about what we want to achieve here. We just want to casually talk about if you're an engineer, if you're in programming, and you want to like get a hands-on understanding about like what happens with stable diffusion, image processing, all of that stuff. So I actually started working at a company which is actually focused around this. So I'm working with a company called Dashtune, and we are actually building comics, and the team is excellent, and I've been learning a lot of things through them, and I think this is just my way of becoming better at what they do. So we build comics using AI, and there's a lot of stuff that's happening with diffuser pipelines, working with different stable diffusion, SDXL, different things out there, and a lot of stuff there. So I sometimes take some time out of my weekend to kind of like pick up some of these and build it, and then learn in public. And this is one of those exercises which I'm trying to do over there, right? So we interesting stuff we're doing there, which I'm a big fan of, because I think one primary thing is that I've been using Photoshop or similar tools for almost 15 to 20 years now, which is quite a long time. And I've been using it as a kid, and seeing how AI is actually being like doing these generative AI and actually creating images out of just a prompt. I think these are like super cool time to be alive and actually building something around it. So doing some stuff around that. So it's pretty cool. So there'll be two things we'll be looking at. One is working with something called Comfy UI, right? So this is a very interesting. It came out like I think sometime 6-7 months ago, and they've actually catapulted the entire community to actually use a node-based program. So this is actually just like each node is a block of code, if you want to think about it, and you're able to like just drag and drop and then give configurations and generate the entire output out. What's very interesting about this is that you actually get very close to programming here. So if you're not a programmer and you still want to play around with Comfy UI, it becomes very good to work with. There might be a little challenge initially when you want to work with, because a lot of people are not very used to working with node-based systems or graph-based systems. So if you've used Rhino, Grasshopper tools, stuff like that, they're also node-based tools. But if this is the first time you're using, I think the flow of what's happening, that is something that might be an initial challenge for you. But I think once you get an idea, you will understand how flexible Comfy UI is, and you're able to automate an entire workflow using this. Some people out there have done some crazy stuff with Comfy UI, so I think a lot of interesting stuff is there, and there are a lot of community stuff also out there. So you can actually just go to Comfy workflows, where they can actually you can share workflows of what other people have done. You can see a lot of stuff what people have shared and how they are managing the community. So a lot of interesting stuff there, right? And some of these workflows are little, you create your custom nodes or your own logic that you want to apply here into Comfy UI. So which is also why there's a lot of community being able to work with Comfy UI. So a couple of things with Comfy UI is that it's a completely node-based system. So you can see I can move this around and it'll show me the entire flow of what is happening and what the input and output of each block of node is, right? So there are maybe 4 to 5 different concepts that you probably need to get used to when you're initially working with Comfy UI. So one of them is basically like these different, and I'm gonna like walk through all of these nodes one by one, right? So if you understood a bit of stable diffusion, or what happens is that you essentially have something called your checkpoint or your model, right? This is where a lot of time is actually spent on training. So let me see if I can just like draw this out. So think of this as your model, right? And this is like quite a heavy file, right? This is it could be between a couple of GBs to 7 GB, 10 GB, which is there. This takes probably maybe a month, maybe 3-4 weeks, depending on what kind of GPU you use for training. And this involves someone to actually have images, right? So you have images here, you have you caption them, you train them on certain parameters, and you like add noise to it, and then like store this in something called a latent space, and your model just has all of this information internally, right? And you are now able to use this n number of like a very large millions and millions of data points, which is stored in this checkpoint or model here, and that is being used. So you have different types. There's like Dream Shaper. This is something which is out of Stable Diffusion, a specific checkpoint summons trained. There is a V1 1.5 version also. This is Stable Diffusion 1.5. There is SDXL. There's many different checkpoints. If you want to check out more stuff, you can go to Civit AI. I think there's a lot of stuff there, or you can go to Hugging Face and see models there itself. If I search for Stable Diffusion, you will see different models that you can see there, and you'll see like how large of these sizes are also. So if you search for SDXL, you will see SDXL Turbo, LCM LoRa. All of these are available for people to download, so you can get it from there, or if you have like a custom one, you can also train that and use it, right? So what we are looking here is an example of how can we generate something from a text to an image, right? So you can see this here on the right side is my final output, right? Which is something like an astronaut in a jungle of sorts. So and what we are requesting comes in a format of like a prompt, right? You can see there's a prompt here which is saying that there's an astronaut in a jungle, cold color palette, muted colors, detailed, 8K, all of that, right? And this prompt can be a positive prompt and a negative prompt. And you can see there's something called a clip text to encode or clip text encode here. Clip essentially stands for a contrastive language image pre-training. This essentially helps move like whatever your text is into like it gets encoded into something which the model is able to understand and work with, right? So that's what clip stands for, and it's basically to move this prompt to something which the model understands, right? So you can have more both positive and negative prompts here. So a couple of things about prompts also is that you can actually increase the weightage of a certain prompt also here. So if you say this has to be maybe HD, you can just put it in brackets and it will increase the weightage for it. Or you can also do something like putting a 1.2 as a weight on that certain prompt, so that you're specifying or you're saying that I want this to be more relevant in the image. This is also something you can do with your prompts, right? So what happens with all of this information is that it goes into this this thing called a sampler. I won't be getting into too much of what a sampler is, because I personally don't think I understand it that well also, but there are different samplers out there which basically defines or explains what your final output is going to be, and your samplers basically help you that. So the entire image which is generated, it is being generated with the help of what we call a sampler. A sampler takes a couple of inputs here. You can see here that this prompt here, right? There's a positive prompt which it accepts. So the left side is basically your input, the right side is the output. So think of sampler as a function or of some sorts, and you're able to put a positive and a negative prompt into it, right? So in addition to it, it also takes the model that you defined here. I've taken a Dream Shaper v4, right? And another thing that it takes is something called a latent image. So this is interesting because a latent image is actually like in this case for a text to image, we give it as an empty image, which means this image just contains just noise, right? Because we are using text to image, and text to image really starts with nothing. So it's just noise that you're starting with, and you're trying to create an image out of it. So in this case, you don't really have any specific information. But if you're working with image to image, let's say you want to put input as an image, right? Let's say your profile photo or anything like that. Then you want to probably use a different image here and then encode that into your latent space. So latent space is also somewhere which the model works on. So your images are actually downsized or probably like shrunk into smaller, compressed into smaller areas in the latent space, and that's where all the processing or noising and denoising actually goes through, right? In addition to this, you have a lot of other information. You have a seed. A seed is nothing but a variation of what your outcome should be, right? Then so if you change the seed, you will get different output every time. But if you want the same image, everything same, and you want the same image out, like for example you want this image out again, you apply the same information there, right? For example, seed here, steps here, all the same. If you configure it, you will get the same output, right? So you can so if you're trying to figure out different, like you want different variations, you can just change the seed and work with. But if you're working on the same image, you want that small incremental changes, same image, you make it fixed and work with it. You also have steps here. I might have talked about this last time also. Steps is nothing but the number of steps involved for the sampler to kind of denoise. So denoising doesn't happen in a single step. It happens through multiple steps. At each step, there's an incremental denoising. So you start with a very blurry or like a noised image, and you do a gradual reduction in that space. Right? So you're improving it a little by little every single time. So some checkpoints, or if you use like something called an LCM, you can have a single step also, but your output may not be the best, but it's much faster to work with. The another thing is something called denoising. Denoising is a parameter to basically tell you how much you're going to destroy that image. Or how much you want to denoise that initial image that you have. So if it's 1, that means you're going to completely eradicate all the initial image and get a new image out of it. So if you're going to work with text image, I think generally 1 is fine, not a problem. And if I go here and actually just click on command and enter, right, you can see this like a green box which says this is the current position of processing. And you can see the number of, like, there's a progress bar that happens here, and this is essentially the steps involved to like if there's 20 steps, there's actually like 20 steps of generation involved to get that output there. So after each step you'll get to see the output, and you can see that this is the final output that comes out of it. And if you see this, you can just zoom in and see the final output that it provides. Right, so the image is also generated at a 512 by 512. This is because the checkpoint was also designed and trained at a 512 by 512 pixels. If you use like an SDXL or something, you'll probably get like 1024 by 1024. You can also control this, but I probably won't touch upon that later. Great. So this is generally what happens with your initial the number of steps here. Now so there's something called post is something called a VAE, right? This is basically so I mentioned something about latent space. So what happens here is that your output is still in the latent space, and it's not actually your final 512 by 512 output. It's still in a very small image that it's doing all the denoising for. So the VAE decoder basically converts that latent space into your final image here, right? Latent space is where what Stable Diffusion understands, and it's a different pixel format. And once you do a decoding, it gives you that final image that you want, right? So it's like a decoder, right? So this is like, I think, the bare minimum you'll get used to create a simple workflow using Comfy UI itself, and you should be able to do a simple text to image. Now if you set up Comfy UI on your system, this might look very different for you. So you'll have to actually install something called custom nodes, right? And so when you clone this repository, right, you will have a set of instructions to install your application. So you can follow that. Depending on your system, it'll be a little different. So some initial setup time is there. You can also do this on the cloud if you want. So like I use Jarvis Labs, for example. So for me, I just have to like go create a new instance here, and you can like run different types of ML models or PyTorch or Jupyter notebooks, anything you want to run that, you'll be able to get here. I think Comfy also has like their own system to run this, right? So if you don't have the GPU, if you don't have the time to like set up everything on your own, just like I just recharge for a couple of dollars and then like use it when I needed to. It saves up my time for like investing into a GPU or like running all of this on my system, right? You also have other, so I have, oops, yeah. So once you set up Comfy UI, you also have to set up something called Comfy Manager. This is like, basically it doesn't come with all these custom nodes for you. So you have to clone this into that custom nodes folder that you have. So you can go to custom Comfy UI custom nodes folder. Over there, you can just basically do a git clone, and you will see. And once you restart your Comfy UI, you will be able to see this manager option. Manager option is basically like it's a menu for you to install custom nodes through this. So you can go and install what communities are adding to this, and you can search and basically add it. So this becomes very simple for anyone to install using the GUI itself, right? So not going to get into a lot of that, but I think once you start exploring Comfy, you will start to see the more specific you want. There's someone else who would have probably already done it, and you want to use their Comfy workflows. If you see a lot of YouTube tutorials or anything like that, some of them might also have custom nodes also. So I'm going to move to another image to image workflow. Okay. This is basically, oops, I think I messed up my image to image workflow. Yeah. So what I would probably want to change here, so this is, I'll have to rework on that right now, but what essentially happens here is that you want to now, instead of just having like a prompt here, right? You want to have your image as part of your initial input. So you can actually go and add an image, right? And you can just say load image here. So you can right click here, add a node, and get your image there. So now instead of this empty latent image, right? You want to now use this image as your initial input, right? But how, like we already discussed earlier, saying that, right? Image, what we want to see, it's not in the latent space. So how will the system understand this? So how you have a VAE decode, you also have a VAE encoder. So you can just right click and select, it'll be inside the latent, and then you'll have a VAE encode option here. So I can basically remove this, and I can use this as my initial image, right? So I have my image basically given as an input for the VAE encoder. I'll also just ensure that this is the same VAE here, right? Because some of your checkpoints already have VAE inbuilt, so I'm going to use that VAE. And now I'm just going to pass this as the latent image. Now if I run this, it is going to use this image as your initial prompt, or it will use this as your initial image for denoising. Yeah, so we can, this initially sometimes takes a bit of time. There are two places where it takes time. One is loading your models, because it's probably a couple of GBs and it has to load it into your pipeline. So that's one place where it takes time. The second is each step probably takes a bit of time. So if your system, if you have a CPU that you're running, it'll probably be slower. If you have a GPU, then you can offload some of the work to the GPU and let it run that. But that's why it basically takes time. So if you use something like a cloud system, it'll much be faster if you have a GPU, that is. So it's going to go through this. Let's see what the final output is going to be. So it's going to be a little odd, because we have given a girl, or there's a simple drawing of a girl here, and that's why it's going to look a little odd. Let's see what that output is. One issue is that we've also given like a one strength denoising here, so which means we will actually be removing a lot of the information that is here, right? So you don't really get a lot of information there. It takes a little bit of that information and then manages it. But if you want a better output, you probably want to make it like a 0.8 or a 0.9 and then do the same thing. All right. So let's try that again. So when you run Comfy, you'll also, because of the Python application, it'll also be running on the background here. And you can see here, this is the progression that actually happens on the background. So if you're just curious about it, you can just always go back to it and see there are certain logs or certain information you want to see. You can just like move to this. So there's many nodes out there. You should definitely explore. I mean, like it could initially be very challenging to figure out what node you need. I think figuring out simple workflows, like if you want a certain outcome, I think just start with text to image, image to image, in painting with mask, going to more applying control nets. Once you do these basic workflows, I think you'll have a better idea of like what kind of nodes do you want to work with. Right. Yeah. So you can see the moment I reduced it to like a 0.8, you can see there's more information of this initial image, which we have maintained here. Right. So depending on like the workflow or how you're working with that, denoising strength can change, but you can use it anywhere between 0 to 1. Depending on what kind of outcome you need, right? So maybe like a 0.92 might be a little better here. Sometimes Comfy UI tends to do quite like they do something, they change that actual denoise to a little bit and give it like it's not always the same. They bring it down to probably, I think, I don't see, sometimes I don't see a difference between 0.81 to 0.86, and then you go to 0.87, suddenly it's like a whole different image. So that tends to happen. So you got to like play around with it. There are different ways to try out which is your correct strength that you want to use. So this is something called image grid XY plot. So you can actually use 0.1, 0.2, 0.3 all the way to 0.1 and then create multiple batches of images also. So that's also something you can actually do with the system. Yeah, this is gonna take a bit, so we're gonna try that out. Yeah, so this is gonna give you probably a little better output compared to your earlier one, but I still like that first one because it's got a very nice final output of the astronaut. So this is something you gotta keep playing around with to get that final output. So if you're interested and if you have a little bit of free time, you should definitely like try out different things here. Yeah, so there are a few more like workflows that you should definitely try out. I think I'm going to give you an example of what you can try or where you can get more. So there are a few places that I think, so if you go to the GitHub repository, I think they have a very nice set of examples here. I think this is good to get you started with different workflows. So this is an amazing place to start with if you're new to the whole platform, and you should be able to like see examples of, for example, working with SDXL or anything like that. It'll give you some info of how to work with it. Right. So yeah, I think I've discussed enough probably about getting a basic intro to Comfy UI. But I also want to now, I don't know if there's questions or doubts around this, but I want to probably go into working with a bit of something called Hugging Face, or using diffusers from Hugging Face itself. Right, diffusers. But if you have any doubts or anything, just drop it in the chat box. I can try to answer whatever I know. Right. Yeah. So I think if you're a programmer, this is probably more fun to work with if you're going to be working with diffusers. It's, I think, super simple. It's not too long since I actually tried it out, but I think it's very intuitive and pretty straightforward to work with. One thing I like, it's just that it takes a lot of memory, and you need to sometimes download all of these models. So it does take a lot of resources, and you need RAM. So I ended up hosting this on the cloud itself, right? So I'm using a Jupyter notebook here to kind of run the system. If you're new to Jupyter notebook, it's more of a interactive Python terminal kind of a thing. So you can create code blocks, and you can run those individual code blocks there. And once you're done with that, it puts it in the kernel of the memory, and you can just basically move to the next code block and then run that again. So you don't have to run the entire app. You can just run specific parts of it again and again. So definitely try out notebooks out there. So this is a very simple example of actually using diffusers from Hugging Face. And you just need to import diffusers, use the auto pipeline for text to image, right? Torch is for PyTorch basically. This is a Python library used for a lot of machine learning processing, or metrics, all of that stuff, right? If you want to work with matrices, PyTorch is very famous in or the industry standard for it. Or now how you can basically work with this is that you can give this, so auto pipeline for text to image, you can give a certain model here as your input, right? I've given here Runway ML's Stable Diffusion 1.5, right? And this here what you see as 2, right? 2 CUDA means basically to use NVIDIA's unified basically graphic processing. So it will try to use the GPU over here. And this is basically loading your model into its memory and ensuring what configuration you want for your pipeline to work. Once you have this loaded, right, you can basically tell, hey, you need the same thing that we gave, right? We gave a prompt, and that prompt you're able to actually give it part of this pipeline here, and it will generate an output here, right? And if I were to run this again, so if I were to let me run this again, it's probably going to load this once, okay, and I can oops. Yeah, this is, let me just give it a second. Yeah, so it's just loading those components right now. So you can see the progression over there. Once the pipeline components are loaded, I should basically be able to now run this and get an output. So here you can see is that I'm defining a certain seed on it, right? Actually, this is probably repeated here. I probably don't need this here. Yeah, you can see here I give that information of pipeline here, and I get this final image here. The reason we did not get anything over here is because we didn't try to print or display the image. If I were to run this again, I'll probably get the output of the image once more, right? So you can see this pipeline is creating this image here in this manner, what we have given here. But if I go and create another pipeline with another image here, you can see that this is what we get now, right? Over here, this is basically the seed that we have informed before. So seed is basically the variation that we need. So if you change the seed here to another seed, and if you run that again, you're going to get a different output here, right? So you can basically control the output and get like the correct image that you want. But if I go back to 32 there, and if I run this again, I will get a very similar output that I wanted before, or I had before. So this is a simple example of similar to what happened in Comfy. We worked with something like a text to image format, and we are able to get a very similar output here. So this is, I mean, my point of view as a programmer, I think this is very simple to work with. As long as you're able to get past the initial setup time and loading all the models, this is actually very simple to actually work with, right? Of course, there's a lot more configurations, a lot more documentation on, because I think the challenge that you probably get is like working with multiple models or working with different types of configurations and getting the right output. And that's something, if you go through the diffusers documentation, you'll have a better idea about. So the next, I think I'll probably talk about something called control nets. So earlier, I think in earlier also, I think in the previous session also I talked about is, so what happens inside Stable Diffusion is that you have there's something called UNets, or basically where all the work happens. It's in a neural network, right? So the name control nets is basically to control these neural networks a little better, and want to control how that diffusion pipeline works, or how that neural net is like getting your final output. Image to image is one of those ways. You give an initial image and you get out of it, but you need more control, right? You need a certain pose of a human being or anatomy to be followed. You can use different kinds of control nets for that. So the one I've loaded here is basically something called an open pose. So if you go to different types of control nets there, you will see this is one of them, and this is basically giving you like it basically what it does is it has your initial image, it creates a pose out of it, right? And you are able to create something similar out of it. So pose works on multiple types of things. You have face for control nets, you have canny for edge detection here, right? So there's many out there. I think I spoke about MLSD in the previous workshop also. There's for image depth also I've spoken about. So you get to actually do this using simple code also, which I think is very interesting to work with. So if you're going to be in MLOps or working with a company which is focused on machine learning, and they have their own pipelines, Diffuser's pipeline is, I think, amazing to work with, and it's to be honest not very tough for if you're still new to the entire space, right? So what we are now loading is basically your control nets. So I'm going to like what you see here as a code is basically your control net model, and we are importing it from the diffusers library. And here you get this is a load image function that we are calling. So I'm just going to run this now. What happens here is that this is the same model. So similar to your checkpoint that you used, we are also just loading the control net model here, right? And again, we are telling that use the GPU here. This is the initial image we want for pose. So if you go open this is your initial image that we are using for retrieving the pose out of it. So now the pose image is here. you should be able to now pass this control net. So you see here from like we are using the same pipeline, which is text to image from pre-trained, same model here. We are applying the control net here, right? We are passing that as an argument or a parameter. And in this time now we're going to generate like we're going to set the seed to 31. Could probably put that below. We don't need that there, right? So once we load the pipeline and say that, hey, this is the new configuration that we need, we can run the next piece of code, which is basically to define the manual seed and define saying that use CUDA, and the same prompt over here, and we have given the post image all that information also a part of this, right? And now when we run this, right, it's going to try to use this as a reference to get that final output, right? And now you can see that it creates this similar post that we had here. So this is super useful, I think, even if you're going to get into animation and like create a video series. It's generally this post that we take out, and you have a moving post, and then each frame is actually generated using this mode here for using posts, right? So it's super helpful. There are different types of post generation also out there, so you should definitely check them out. This is, yeah, so control nets, I think a very large topic itself. There's many types of control nets you can use for different types of outcome you need. You can probably mix and match a couple of other control nets together also. This is a simple example of getting a different height and width. I think I spoke about when we were talking about Comfy also, like initially 512 by 512, but your final output you want a little different. You can control that here. And when we run this, it will basically give you that final output. If you use very large images, it may get a little slow, and it can be problematic because Stable Diffusion might end up putting multiple characters or multiple astronauts in the same image, right? So that could also happen. We have not defined the seed here, so we get every single time we generate an output here, we are going to get a different output. Right. So there's another like one of the other parameters is also something called guidance scale. A guidance scale is basically like it matters on basically how much the prompt is going to help you adhere to the final output you need. So there's generally we use maybe 7-8, but depending on the pipeline, depending on what you want to use, maybe if you're using LCM LoRa's or LCM pipeline, generally probably we may use lesser guidance. So this is something you got to play around with and figure out what works for you best. But I think generally 7 to 8 works. But if you're using lesser number of steps, you can also, depending on LoRa again, it can be varied, maybe 2 to 3 also. We have used sometimes 2, 3, but people have also seen great output at 7, 8 also. Right. All this is not loading, seems to be stuck. Yeah, not sure why the notebook is not responding. Now, in addition to guidance scale, like these are just different arguments that you can actually give to your so these are just different configurations, right? So if you just like change this, for example, add a negative prompt, this is just one parameter that we're just passing more. So your final output might have 6 to 8 different parameters, maybe 10, 12 parameters you want to get for getting that final outcome, right? Although this is not running for some reason, I'll have to check that. Yeah. As I can see, eyes example eyes are not very best in the generated image. How do you deal with professional character creation? So there's more aspects to it. I think because we are not really defined like I've not gone through each and every parameter out there. But if you specify different, like the number of steps and the guidance scale and many of these individual parameters that you define, your final output will become better and better and better, right? So like figuring out or understanding what parameters you have to use in the end, I think that becomes a lot of trial and error to actually get there, right? You have to do like something called a parameter sweep to kind of figure out, hey, these are the parameters that work for us, or this is how parameter A is affecting that output, right? So you can fix your seed, change different parameters, and then we do something called a design of experiments, and then figure out, what parameter A is like when I move it to this certain area, it's actually giving me like good output when I fix all the other parameters. So this is how you figure out what parameters work for you, and then figure out, this is the combination of parameters that I want to work with, right? So that also, plus I think if you're being more better specifics, like one important thing is about using negative prompts, right? So yeah, so this last part that I was writing here is basically negative prompt. So we like you can define, or you can tell the stable diffusion system also tell that, hey, you want you don't want a very deformed or disfigured object out there. So you can give more negative prompts to actually improve the quality of the output. So you can see this is probably a little better compared to the other one, because this is representing a human better. So if I put this as so if I say Isaac Newton instead, right, and the output that you get will probably be a little different of a person itself, right? So again, you can see terrible like eyes coming out of it, but depending on, once you change your like parameters, you will get different outputs there. So yeah, so you can see here, like this is probably a little better than what we saw earlier, but definitely not the best output that you can get, right? So there's many ways to apply this. Like I'll just show you maybe an example of our actual character generation, or probably when so this is like part of our company, what we're building. So this is like a web-based platform for actually creating comics and stuff. So I'm just going to like show an example just for reference on how this works here, right? Yeah, these are all like a lot of testing characters that we have. Probably go to dash in style. Yeah, so if I use this and like do a generation here, right, obviously we have more production grade systems here. You will get much better outputs here though. This is probably a CDN issue. Like that's probably like a network issue on my side, which is why I'm not seeing an image here. Okay, let me go back and just show you some examples of what has worked, right? So this is an example of like a comic which I made using the platform, right? And yeah, this is definitely a network issue. I'm not able to load my images. I'm just gonna log into my so let's actually just take an actual comic someone's probably built also. I think we'll be able to see the images generated. So this is an example of like some of this is actually generated, or most of it is generated on the platform itself, and we help in creating that whole process together, or stitching that whole process together, right? Not able to get the entire image out. Oh, yeah, this is coming now. So you can see here, this is like individual characters that I was able to like generate out of you can see maybe some information of the prompt, right? And I was able to get an output in this manner, right? You can see here, this is a very specific input I created here, right? And I was able to get different outputs there. So it's a lot about figuring out what prompts you want to use and then generate like the final output there. So figuring out as probably one as an engineer, you probably have to figure out what parameters work for you, but we basically simplify that whole process and make it easy for any creator to come on the platform and build it. But yeah, like I hope that answers your question. And another thing is also consistency. So how do you get consistent character creation? This is there's a process called LoRa, or creating like new characters and stuff like that, and that happens through a process through LoRa. You can create more custom characters through it, right? But that's a whole different ball game altogether. I'll probably touch about that later. The idea of this session again was to kind of break the ice and kind of tell that, hey, things are not so difficult here. It's like, I mean, of course, making the final decision and getting in production grade, there'll be a lot of learnings involved. But if you want to get started and get an idea of, hey, how do I, as an engineer or probably as an individual, how do I get started with these tools there? I think this is a very great way and simple way to work with. Right. Cool. So I want to do more like stuff on diffusers and kind of create more detailed out pipelines over the future. But I think today I wanted to kind of cover very basics, so that I think anyone who has even a hint of knowledge of programming should be able to just write this out and get like a good output. I think that was the idea here, trying to keep it as beginner friendly. I'm not sure if it has come off as beginner friendly, but I think this, in my point of view at least, I found it simple, and I think anyone can easily start from here. If you want to get more with diffusers, you should check out Hugging Face documentation. Half of the things you see here is from there itself. It's very simple to work with. They have a lot of nice interesting stuff there. You can check out. I think you should probably start with simple tasks like this, right? Image generation, text to image, right? Working with inpainting, all of that stuff. And these are not heavy code. This is very like 5-10 pieces of code to just get started with it, and then get into a little more specifics about how to go about improving outputs and all of that. Right, then you will know more about what the pipeline, what kind of arguments or what kind of APIs you can use along with it. But I think this will be probably like a great start for anyone out there. Cool. Yeah. So I don't have anything more to discuss today. But thanks whoever was able to join. Thank you for joining in. I hope it was a good learning outcome, and I'm going to keep the video available for someone who's able to join later and see it also. I did not plan this out very well, to be honest. I decided this morning that I will take it up today. So it did not have a lot of time to prepare, but I want to do more of these and probably inform people more in advance, and then give maybe do some offline events later. But right now, just doing some doing this for fun and for learning itself. I hope if you have any requests or if you want more stuff, do comment or probably message me somewhere. Cool. All right. All right, I think we can wind up here. Thanks everyone for joining in.